Yeah, types of machine learning, right? As the professor covered in week one, mainly two types of machine learning: supervised learning and unsupervised learning. There is also reinforcement learning, which we'll not cover in this course. But yeah, I mean, reinforcement learning is rarely used in common day life. Maybe if you are you know making a game or something like that, like Deep Blue or something, which can play chess. And yeah, yeah. So those request reinforcement learning, but majorly we'll focus on supervised learning and unsupervised learning. So as the professor mentioned, supervised learning is when you have a categorized data set. So by categorized, I mean like, uh, okay. So let's come to the example that I gave earlier. You have some, a set of animals given, and you have been tagged. Those animals are tagged. So this is a cat, this is a dog, this is a horse, and so on. Right. But on the other hand, in unsupervised learning, you're just given some data. You don't know which one is which. You don't have the output parameter. You don't have the y variable, right? So that is when unsupervised learning comes into play. So, for example, um uh, well, let's see. Okay. Uh, so clustering is one of the examples, which will come back later. But yeah, for example, in supervised learning, I will come to one example each. But if you want to share any example of supervised learning and unsupervised learning, you can just talk about it. But I will go through each of the examples of supervised and unsupervised learning in detail, and I will solve some examples as well. But if you have any example of, supervised learning is easy when you have a tag data. So one of the examples that I come to in the next slide is, housing prices. So let's say you have a house which is a big house, right? It price will be more, right? So I mean, considering that all other factors remain constant, if you have a bigger house, the price will be more in general. If you have a smaller house, its price will be less. Right. So that is an example of linear regression, right? Uh, so you know what is the price of the house, you know what is the size of the house, and based on that, if a new house comes and you know what is the size, you can predict what is the price of that house. So that is an example of linear regression, which will just come in the next slide. Whereas unsupervised learning is that, let's say you have some houses of different sizes, right? But you don't know like what is the price of each of the house. So let's say there are only small sizes houses and there are only big sized houses, right? And there's no houses in between, no houses of medium sizes, right? So then you can apply clustering and say that, okay, this is a cluster of a big sized houses, this is a cluster of a small sized houses. And yeah, now why do we do clustering and those things? Those will again, I'll come to that, and those have some market market strategies. They develop market strategies based on clustering. So if you have one cluster, and based on that you can develop insights on that cluster. So let's say the big sized houses, you can get some feature from that. Okay, big sized houses have these common feature, whereas small sized houses have this common feature. They have, let's say they have um lesser number of rooms, whereas big size houses have a more number of rooms. I mean, this seems obvious, but you can come up with some. In general, we don't have some such obvious insights, but so this is basically just to understand that bigger size houses have bigger number of rooms. So let's say a customer comes to you and he asks that, okay, I have a big family of, let's say, 5 people, and I need at least 3 rooms. So you will not go take that customer to show a small size house. Okay, you'll take that customer to a bigger size house, because by clustering that that bigger size houses have this cluster has a larger number of rooms and so on. Right. So those are some of the insights that you can get from clustering and unsupervised learning, so to say. So these are some examples of clustering. Like clustering can be done by k-means, mean shift k-methods. I will not go into details of these because they will covered in the upcoming weeks. And dimensional reduction, PCA, feature selection, linear discriminant analysis. These are some examples of unsupervised learning. So, I will not go into detail of each of these algorithms, but I will just say what dimensional reduction is. So, let's say you have a data which has, 1,000 features. For example, again, come to the housing prices. So, price of the house can be determined by size, that is one feature. Second feature could be number of rooms. Third feature is location of the house, whether it's located in a well connected place or is located in a remote place, and so on. There are like 1,000 features, and you cannot plot all those features in your plot and visualize, right? You cannot draw a 1,000 dimensional graph, right? Uh, so what you do is that you reduce the dimensions of the data, and then you see which feature is most important to us. So all the features won't be, equally important to determine the housing price. Let's say size of the house contributes more to determine what is the price of the house, whereas location might not contribute that much. So you reduce the dimension of the data, and then you can also see like which component contributes more to determining the price of the house, and you can also visualize visualize the data uh, better. So that is what dimensional reduction basically means. Again, regression comes in linear. It will be linear regression, logistic regression, decision tree. So I'll talk about linear and logistic regression. What is the difference between them in the next slide? And okay, classification, again, it could be naive Bayes, SVM, or KNN. So one difference between regression and classification is that, so let's say the housing price is the best example of regression, where the output is continuous basically, right? The price could be anything, uh, any number basically. Whereas in classification is the earlier example that I talked about is the spam classification, right? Spam classification. There's an example of classification learning, and so where you have like the output variable can only take 0 or 1, positive or negative values. So whether it is a spam, then it's 1. It's not a spam, it's a 0. So yeah, only those two values the output can take. No other values. Right? So that is a classification. Right. So any questions on this example of reinforcement? Yeah. Yeah. Sorry. Yeah, go ahead. Right. Right. So okay. Let me let me think of an example first. Mm, Okay. So let's say you are like a biologist, working in a lab, and you're working on rats. The rats have. So you're considering only whether the rats are obese or not. So your problem statement is to understand whether the rats are obese or not, and what is causing this obesity, right? So you have some data about the rats. So let's say the obesity can be caused by three of the genes that are present in the rat. So you know what is the percentage of gene 1 in each rat, gene 2 in each rat, and gene 3 in each rat, right? So it's a three-dimensional graph, right? So you know what is the percentage of gene 1, you plot this, and gene 2, you plot in the y-axis, gene 3, you plot in the z-axis, right? So now what you do is that, so it's a three-dimensional graph. You cannot draw a three dimension in a two-dimensional paper, right? I mean, even if let's say you have like in practical cases, you will have many more dimensions actually, not even three. You'll have like thousands or something like that. Let's say. So what you do is that you cannot visualize, right? You cannot like see. I mean, you can plot them in 1,000 dimensional data, but you cannot see the graph, right? You can have a 1,000 dimensional array, but you cannot see which gene is contributing to which what obesity basically, right? That's what you want to know. So what you do is that, you reduce the dimension of that data. Again, I will not go into detail like how you do it. That I will do probably when the professor teaches PCA or something. You basically from gene 1 to 100, you reduce to two axes when you have like a combination of genes. So in the x-axis you will have certain combination of genes. So let's say gene 1 plus some factor times gene 2 plus some factor times gene 3 and so on. In the y-axis you will have again some certain combination of you know all those genes, um, and then you can like you will only have the x and y axis, and then you can plot your where that particular mice stands, right, in the two-dimensional data, right. So from a 100-dimensional data you have reduced your dimension to. Okay, is anybody in? Okay, so if from a 100-dimensional data, is everybody on mute? I think I'm getting some echo. Maybe. Okay. So from a 100-dimensional data, you can reduce it to a two-dimensional data where you can plot, uh, uh, you know, uh, what is the proportion of genes that mice has, you know, and yeah, in that way also, since your axes are a linear combination of the genes, you can also determine like which gene is contributing most to, let's say, obesity or whatever. So that is a way to visualize your data, and yeah, that is basically dimensional reduction. Is that okay? Or